Hi everyone, I welcome you to Dynamic Coaching Center. So today we'll be dealing about heat and wave equation. So for this particular session, I'll be dealing only with wave equation. So before even getting into the problem, so let me define you what are all the different types of wave equation problem you'll be handling and how to differentiate that. So the particular first thing what we are going to see is zero initial velocity problem, and how to identify whether this problem is actually zero initial velocity problem is very simple. If the term displacement or f of x is actually given in the question, then you can confirm that that is a zero initial velocity problem. In that there are actually two type. One is they can actually specify you the displacement as y is equal to sine term or cos term, which is nothing but trigonometric functions, or they might even specify you the displacement y as an algebraic term like kl into x minus 2lx, something like that. Okay, so once again I'll repeat you, zero initial velocity problem can be easily found out whenever the term displacement y or f of x term is given, then that should be a zero initial velocity problem. Out of that, the displacement could be either a trigonometric function like sin x or cos x, or that could be an algebraic term like kl into x minus 2lx. Then the second type would be the length of the string which is actually vibrating will be for a length L, or it could be for the length 2L. So these are the two things which is often been asked in so many universities. Then the next type of problem would be the non-zero velocity problem. How to identify whether this is a non-zero velocity problem is they would directly specify you the velocity or dou y by dou t, because once you differentiate the displacement with respect to time, you will be getting the velocity. So in the question, if they specify you as velocity or dou y by dou t, both are same thing, then that particular question is actually belonging to a non-zero velocity problem. Okay, so let's get started and proceed on. And these are the few basics which you have to remember. Sine cube theta can be written as 1 by 4 3 sine theta minus sine 3 theta. Sine n pi value is actually 0 and cos n pi value is minus 1 whole power n. And whenever you have two variables in multiplication in the integration term, integral u dv can be written as uv minus u dash v1 plus u double dash v2 minus u triple dash v3, and this series moves on. So in this, if you actually notice down this term u, this u dash is nothing but the differentiation of u term, and similarly u double dash is nothing but the differentiation of u dash. Similarly, this is your v, which is actually being obtained by integrating this variable dv, and once again if you integrate this v term, you will be ending up with v1. Similarly, once again if you integrate this v1, you will be getting the term v2. Okay, then out of the two given terms, which one you have to choose it as u is actually based on this rule, I late. I is nothing but your inverse function. So inverse in the sense sine inverse, cos inverse, something like that. L stands for logarithmic, which means log x, log 1 plus x, like that. And similarly, A stands for algebraic, which is x square plus 1, klx minus 2lx. And T stands for trigonometric functions like sin x, cos x, sin 2x, cos 2x. And E stands for exponential, which is e power x, e power 2x, something like that. And this is a basic integration which you should know. Integral sin 2x is minus cos 2x by 2. Whatever it is present as the coefficient of x, that should be included in the denominator term. Similarly, integral of cos 2x would be equal to sin 2x divided by 2, because here the coefficient of x is found to be 2, and that is also included here. So let's move on to a problem. A string is stretched and fastened to the points at a distance of L apart. Motion is started by displacing the string in the form of y is equal to a naught sine pi x by L. As I already told you that y, the displacement term, is actually given, and this problem actually have the string length as L, so that the length actually varies from 0 to L, from which it is released at time t is equal to 0. Find the displacement at any time t. Okay, so whenever you first identify that this belongs to a zero initial velocity problem, since displacement is actually given, you can directly write down this equation. The one-dimensional wave equation in general is represented as dou square y by dou t square equal to a square into dou square y by dou x square. Okay, next the solution for this differential equation can be assumed in many form. So let me take this as my general solution. Y of x comma t is equal to a cos px plus b sin px into c cos pat plus d sin pat. Okay, so for all the zero initial velocity problem, these are all the boundary conditions which you are going to apply. Totally you have got 4 constants a, b, c and d. So you require 4 boundary conditions to evaluate that. So the first boundary condition is y of 0 comma t. Just read this y of x comma t. So instead of this x you are actually going to substitute 0 and you are going to equate this y term to 0. So before even applying this particular boundary condition over here in the equation 1, I'll straight away tell you the answer that you will get the answer a as equal to 0. Just try to remember this so that it will help you a lot. Similarly, the second boundary condition is y of L comma t equal to 0, which means instead of this x I'm going to substitute L and I'm going to equate this displacement answer as 0, because you know that both the ends of the string will be attached, so that you don't find any lateral or vertical displacement, so that you are making this y term should be equal to 0. When you apply the second boundary condition in the first equation, you will be getting this answer p is equal to n pi by L. Similarly, your third boundary condition is you are going to differentiate this displacement with respect to time, which means dou by dou t of y of x comma 0, which means instead of this time you are going to substitute as 0, which means initially at the initial position you don't find any displacement actually. So your velocity term, because once if you differentiate the displacement with respect to time, you are getting velocity, so that here it is 0 initial velocity, so that it should be equal to 0. Similarly, your fourth boundary condition is y of x comma 0, which means at time t is equal to 0, the displacement is actually given in the question. So whatever function given in the question, that has to be equated. Okay, so these are the 4 boundary conditions which you are going to apply. So let's see one by one. So let me apply the first boundary condition. My first boundary condition is instead of x I have to substitute 0. So if I put 0 over here, cos 0 term will become 1. So I will have my a term alone left over here. And if I put 0 over here, sin 0 will be 0, so 0 into anything will be 0. So out of the entire 2 terms in this bracket, I will be left out only with a, and this particular term will be as such, it will be available. Then what I have to do is I have to equate this y equal to 0, which means instead of this place I am going to put 0. So that's what shown here, which means you will be left out with a into c cos pat plus d sin pat, right? Okay. Now already I told you that you will be getting a is equal to 0, but you have to write it in this format. This entire term cannot be equal to 0. Why? Because if this entire term is equal to 0, then the entire displacement itself will become 0. Then there is no meaning for that. So that you will conclude that a should be equal to 0. Okay. Now before even applying the second boundary condition, you have to substitute this a is equal to 0 in your equation. So if I substitute a is equal to 0, this term vanishes and you will be left out only with b sin px and this entire term. Okay. So mark this as your equation 2. Now to this equation 2, you have to substitute your second boundary condition. What was your second boundary condition? Instead of your x, you have to substitute L and your y term should be equated to 0. So let's do that. So instead of this x, I am going to substitute L and this entire left hand side term should be equated to 0. Now what are all the different possibilities? Either b term can be equated to 0, or sin pl term can be equated to 0, or this entire term can be equated to 0. But I already told you that this entire term cannot be equal to 0, because if it is equal to 0, this entire y would be equal to 0. Then there is no meaning. So if then what is the other possibility? Your b can be equal to 0. But already we found that a is equal to 0. Suppose if b is also equal to 0, then again 0 into anything would become 0. Again there is no meaning. So the only possibility is your sin pl can be equal to 0. So remember this, you have to write that it should not be equal to 0 and then conclude that sin pl should be equal to 0. So I already told you that sin n pi is actually equal to 0, which means pl is equal to n pi, and you know that p is equal to n pi by l. So which is what I have already given, that by applying this boundary condition always you will get P is equal to n pi by L for any zero initial velocity problem. Okay, then after obtaining this I have to substitute this in my latest equation, where these are all the terms containing P. So instead of that P I can substitute n pi by L. Okay, now mark this as your equation 3. Now before applying your third boundary condition, you need to differentiate the given equation with respect to t. Okay, so let's do that. So you're going to differentiate this displacement with respect to t. So here this is constant and this entire term doesn't have any t term, so both these terms are constant, and this is found to be in multiplication with this entire term. Now entering into this term, c is again constant, and this cos term contains the term t, right? Actually you are differentiating with respect to t. Now cos differentiation would give you cos differentiation would give you minus sign, right? So let me put minus and write this entire term as sin n pi at by L. Remember what I have told you in the integration. So if you actually differentiate it, cos term would become minus sign. Then remember that you are differentiating with respect to t, right? So the coefficient of t term should be put in the multiplication. Okay, so don't forget that. So that the t coefficient would be n pi a by L, which has to be included in the multiplication. Then I will go for this plus sign again. Then this t is constant again, and sign differentiation will give you cos. So I can directly write this, and you know that t coefficient is n pi a by L, which has to be again included in the product. Okay, now we have got dou y by dou t of x comma t. Now let us apply our third boundary condition, where instead of t you have to substitute 0 and then equate it to 0. Okay, so instead of this t I have to substitute 0. This is the term containing t. If you substitute 0, sin 0 will become 0, so this entire term will become 0. And here also you can substitute this t as 0, so that cos 0 will become 1. So still you will be left out with d and this n pi a by L. Okay, and then you have to equate everything to 0. So which means now you are getting bd n pi a by L into sin n pi x by L. So what are all the possibilities you are getting is, you can either equate b to be 0 or d to be 0, or this n pi a by L term should be equal to 0, or this sin n pi x by L term can be equal to 0. But remember, already I have told you the answer that by doing so you'll be getting d is equal to 0, but you have to write that b cannot be equal to 0 for the same reason what I have told you above. Similarly, this sin n pi x by L cannot be equal to 0, which has already been proved, and so the only possibility left out is d should be equal to 0. So after finding out this, go to your latest equation, which is equation 3, and substitute d as 0, so that 0 into anything will become 0. So now these are the two terms which is left in the displacement part. Okay, now before even applying the fourth boundary condition, you go for the most general solution. The most general solution of expansion of any function is given by summation n equal to 1 to infinity cn sin n pi x by L into cos n pi at by L. Just compare your fifth equation with the fourth equation. Your fourth equation also contains sin n pi x by L, and your fifth equation also contains sin n pi x by L. Similarly, your fourth equation contains cos n pi at by L, and your fifth equation also contains cos n pi at by L, which means you can conclude that your BC is equal to Cn. Now to find Cn, you have to apply your fourth boundary condition. What was your fourth boundary condition? You have to substitute t as equal to 0 and then equate it to the given function in the question. Okay, so let's do that. So I'm going to substitute t is equal to 0. By doing so, your cos 0 term will become 1. So you'll be left out with only Cn and sin n pi x by L. Okay, now that should be equated to the given function in the question, which is a0 sin pi x by L. Okay, now we can just expand this series. So you know that it is 1 to infinity, and this is summation symbol, right? So let me put n equal to 1 over here and 1 over here, so that you will get c1 sin pi x by L. Okay, then this is summation, so you have to put plus symbol and go for your number 2 can be substituted in the place of L, which means it will become c2 sin 2 pi x by L. right? Similarly, due to the summation, you will go for the third term, right? And then just put the series as dot dot dot, and right hand side term contains a naught sine pi x by L. Now try to equate the coefficients. So here you have got sine pi x by L, and here also you have got sine pi x by L, which means your a naught will be equal to C1. So that's what you are concluding. Here you have got sine 2 pi x by L, but in the right hand side you don't find any term like that, so that your C2 will be equal to 0. Similarly, C3 will be equal to 0. Until the end of the series up to infinity, you will have all the constant values equal to 0. Now let us substitute this C1 is equal to a naught in this equation, so that this n can be replaced by 1, and here also it should be 1, and here also it should be 1. So instead of this C1, you can actually put a naught. And you know that since all the constant terms are equal to 0, your series won't go up to infinity. So this is your final answer. Okay, let's see how to proceed on with another type of problem. So this is a uniform string of length L, which is stretched and fastened to the points x equal to 0 and x equal to L. Motion is started by displacing the string in the form of curve y is equal to kx into L minus x. So again the term y is given, which is nothing but the displacement. So again you are concluding that this is a zero initial velocity problem, but this is an algebraic equation. And then released from the position at time t is equal to 0, derive the expression of the displacement of any point of the string at the distance x from one end at time t. So here you can actually refer to the previous problem, where actually you can repeat the same step. So I will just show it. So this is your first equation, second boundary condition, third boundary condition, the same one-dimensional wave equation, the solution. So up to your equation 5 remains same, right? Because the only change what you are doing is by applying the fourth boundary condition, so which has been applied only over here. So up to equation 5 everything remains same. So this is what your equation 5. Now let us try to apply the fourth boundary condition, which is nothing but you have to substitute t is equal to 0. By doing so, cos 0 term will become 1. So you will be left out only this term. And you have to equate this with your given quotient function, which is kx into L minus x. Last problem we have seen that this to be a sine term, so that we try to expand this series and equate the coefficients on both sides. But here in this particular problem, on one side of the equation you are getting sine term, on the next side of the equation you are getting the algebraic term. So what we are going to do is we are going to find out the Cn value through half range sine series. So this is a formula to find out the Cn value, which is 2 by L integral 0 to L, and you have to include your function given in the question, which is nothing but kx into L minus x. Let me multiply this kx inside so that it will become klx minus kx square. Then this has to be multiplied with your sine n pi x by L dx, right? So this is what the integration which I have told you, which is u dv. This is also a x function and this is also an x function, but this is an algebraic and this is a trigonometric. So let me compare this with u dv, so that my series should be equal to uv minus u dash v1 plus u double dash v2 and so on. Okay, now out of these two terms, which one has to be selected as u is very simple. Which term is actually exhausting due to differentiation, that has to be taken as u. Or else you can follow that I-late rule, which I have included in the previous paper, where you don't find any inverse and you don't find any logarithmic function, but you find the algebraic term klx minus kx square. So I'm going to take u as klx minus kx square. Now in order to find u dash, you have to differentiate this u with respect to x. If you differentiate x, it will be equal to 1 and this constant term will be left out as such. Then I'm going to put the same minus sign over here and I'm going to differentiate this x square as 2x, so it would be 2kx. And again let me differentiate this u once again, so that this constant differentiation would be equal to 0 and this x differentiation would be equal to 1, so that it would be minus 2k. Again I'm going to differentiate this so that it will become u triple dash, so that it will become 0. So you have to repeat the same procedure till you get 0, because this is a series, this will try to continue endlessly. So now I conclude that u triple dash term is equal to 0, so I don't need any further terms in this integral series. Now you have chosen your u and you have done all these things. Similarly, this dv is nothing but your sine n pi x by L into dx. Okay, now we want v, right? So you can integrate this dv so that it will become v. Again, you have to integrate this right hand side also. So sine integration will actually give you minus cos. So let me put minus cos n pi x by l as such. Then x coefficient is n pi by l, right? That has to be included in the denominator so that it will become inverse. So it is l by n pi. Similarly, watch it over here. Now I am going to integrate this v so that I will end up with v1. So let me put the minus sign as such. Cos integration would give you plus sign. Then similarly again x coefficient n pi by l should be included in the denominator so that it will again become l by n pi. Already you have l by n pi, so that it will become l by n pi whole square. Similarly, if you want your v2 term, again you have to integrate this. Now by doing so, your sine integration would become minus cos. Already you have minus, so it would become plus. Similarly, again you have to include in the denominator as n pi by l so that it will become l by n pi whole cube. So by doing so and substituting in this series of uv minus u dash v1 plus u double dash v2, so I'm getting all these terms, right? And this 2 by l over here is nothing but the formula term which is present over here. Now you have to substitute the limits 0 to l. So instead of this x, you have to substitute l. So let me substitute the upper limit. So if I substitute here l, it will become kl square. Similarly, if I substitute l over here, it will become kl square. So kl square minus kl square will become 0. Again, I need to substitute l over here, but 0 into anything is going to be 0, right? So let me put 0 over here. Similarly, by coming to this term, let me put upper limit l here. So it would be kl minus 2kl, right? But if you put l over here, this l and l will get cancelled so that you will have sine n pi. Already we know that sine n pi is 0, right? So that again your this term is also becoming 0. So okay, now let me put the upper limit to this term so that by doing so you will put l over here and this l and l will get cancelled so that cos n pi will be the term left out and minus 2k will be left out and this n cube pi cube by l cube will be left out, or you can actually write as l cube by n cube pi cube. Okay, now all the upper limits have been finished. Now let me denote minus sign and then substitute my lower limit. Your lower limit is actually 0. Let me substitute 0 over here and 0 over here so that 0 into anything would become 0. Okay, that's what written here. Then again minus is present over here. Let me substitute this 0 to the x over here so that still you will have this kl term. But if you substitute 0 over here, sine 0 would become 0. So 0 into anything would become 0. So that's what substituted and shown over here. And similarly, let me substitute 0 over here in this x term so that cos 0 will actually become 1 and you will be left out still with minus 2k by n cube pi cube by l cube, right? Okay, now let me do the necessary simplification. 2 by l is there. From these both the terms you can actually take n cube pi cube by l cube common and 2k as common so that you will end up with 1 by n cube minus, and instead of this cos n pi you can substitute minus 1 power n, and instead of this cos 0 you can substitute 1, right? So you are ending up with 1 by n cube minus 1 whole power n by n cube. Since both these terms contain the same denominator, you can actually gather it and write. So you are ending up with this equation, right? Now what you can do is, now instead of this n, if you substitute 1, it is minus 1 whole power 1, so that it would be minus 1. So that minus of minus here, so it would be plus 2. So 2 into 4 would become 8. So not only for 1, for any odd substitution or for n, you will end up with this answer, right? Suppose if it is an even substitution like 2, you will have plus 1. So 1 minus 1 would become 0. So Cn value has got two things. One is if your power n term is odd, you will end up with this. If it is even, you will end up with 0. Now after finding out the Cn, as usual, you are going to substitute that in your equation 5 over here. Okay, that's all about this problem. So let's move on to our type 2 problem, which is your non-zero initial velocity problem. So hope you remember that your non-zero initial velocity problem would be identified as you will be given with the velocity in the question or the v term, or it would be the dou y by dou t term. So here dou y by dou t term is given and also velocity term has been mentioned. So this should be your non-zero initial velocity problem. So again we are supposed to find out the displacement y of x comma t at any position. Again the same one-dimensional wave equation has to be included, and the same solution what you have seen in zero initial velocity problem has to be included. So the first two boundary conditions are one and the same what you have seen for the zero initial velocity problem. Again instead of x you are going to substitute 0 and equate your displacement y to be equal to 0, and the answer while doing so also remains the same, which is a equal to 0. Similarly, the second boundary condition, instead of x you are going to substitute L and equate your y term should be equal to 0, and the same answer you are getting, p is equal to n pi by L. And friends, I will tell you one thing, that suppose if your length is not L, instead they have given 2L, if so you will end up here as n pi by 2L. Okay, just try to do that. If you have any doubts, please do mention in the comment section. Let me gather it and represent it as a video. Then the third boundary condition is changed over here for the non-zero initial velocity problem, which is y of x comma 0, right? Which means instead of t you are going to put 0 and you are going to make that displacement term as equal to 0. Okay. So which means initially when the time t is equal to 0 there is no displacement. So that is the meaning. By doing so, please remember that you will be getting the answer c is equal to 0. Similarly, your fourth boundary condition would be equal to, you are going to differentiate this and then make it as a velocity and substitute t is equal to 0, and you know that this is nothing but the given function in the question, which is v naught sine cube pi x by L. So I'll try to tell you an easy way. First two boundary condition, this solution and this entire wave equation remains one and the same for zero and non-zero initial velocity problem. Your third boundary condition for the non-zero initial velocity problem would be the fourth boundary condition of what you have seen in the zero initial velocity problem. But the only difference is you have made your right hand side term as 0. And similarly, the third boundary condition what you have seen in zero initial velocity problem has been included here as a fourth boundary condition, but the only difference is you will equate this to the function given in the question. So you will be doing in the same manner. So hope you will be able to do up to a is equal to 0 and p is equal to n pi by L, everything, right? Okay. Now suppose if instead of L, if you want to substitute 2L, then you will be having sine p 2L, right? So that if you are equating it to sine n pi, you will end up with n pi by 2L. That's what I have mentioned there. Okay, then after applying your second boundary condition, it remains one and the same for both the types. Now let me apply the third boundary condition. You know, third boundary condition is instead of t you have to substitute 0. So this is the two terms which I actually carries the t term. So if I substitute t is equal to 0 over here, cos 0 will become 1. So you will be left out with the c term. And if you substitute t is equal to 0 over here, sin 0 will become 0. So 0 into anything will become 0. So you'll be getting bc sin n pi x by L equal to 0. Now you have got three possibilities. Either b could be equal to 0, or sin n pi x by L term can be equal to 0, or c term could be equal to 0. Already you know that a is equal to 0. Suppose if your b is also equal to 0, then again the entire solution will become 0, so it will be meaningless. And this sin n pi x by L term cannot be equal to 0 because already you have equated to 0. So the only possibility is c should be equal to 0. So if I put c is equal to 0 in this equation, so I will be left out with bd and then these two sign terms, right? Okay. Now you have to compare before applying your last boundary condition. Always you have to go for the most general solution. So here in this case it is a summation n equal to 1 to infinity cn sin n pi x by L, because that is the term what you are getting. Similarly sin n pi at by L has to be included. So these two terms in these two equations are one and the same. So by comparing, so your bd is nothing but your cn, right? Okay. Now in order to find out the cn, before applying the fourth boundary condition, you need to differentiate this, because your fourth boundary condition is nothing but dou y by dou t. So you have to differentiate this equation, which means you are going to differentiate with respect to t. So again cn is constant and the sin n pi x by L term is constant. So this is the term contains t. So sin differentiation would give you cos, and remember t coefficient is n pi a by L, which has to be multiplied over here. Now your boundary condition should be applied. T can be now given a value of 0. By doing so, here you will substitute t is equal to 0, so that cos 0 will become 1, right? And that has to be equated to the function given in the question, which I have done as v naught sine cube pi x by L. Okay. Now what you can do is, in one side of the equation it is found to be sine n pi x by L, whereas here it is sine cube. So you have to somewhere change the sine cube term to sine or cos, which means the power should be equal to 1. So you remember this formula, sine cube theta can be written as 1 by 4 3 sine theta minus sine 3 theta. So just compare this. Instead of this sine cube theta, you are having sine cube pi x by L. So instead of theta, you can substitute pi x by L, so that you will be getting 3 sine pi x by L minus sine 3 pi x by L. Okay. Now this v naught by 4 term can also be multiplied to both of these terms. Okay, and to this left hand side, what you can do is, instead of this n, you can go for 1, so that you will end up with pi a by L c1 sine pi x by L, right? Then you have got summation term, so you have to put plus symbol, then substitute 2, so that it will become 2 pi a by L c2 sine 2 pi x by L, right? Then again summation, so plus, so 3, n has to be given now 3, so it will be 3 pi a by L c3 sine 3 pi x by L, right? So that is what the series will go, and now this can be again equated to your right hand side. Okay, now to your left hand side you are getting sine pi x by L, to the right hand side you are also getting sine pi x by L, right? So your pi a by L c1 should be equated to 3 v naught by 4, right? By doing so and rearrange your c1, you are getting your c1 answer, right? Similarly, you have your sine 2 pi x by L term in the left hand side, but you don't find any such term on the right hand side, which means c2 should be equal to 0. Similarly, third term is also available on the left hand side, but in the right hand side you don't find any term. So you are getting sine 3 pi x by L term here and also in the left hand side of the equation, so that 3 pi a by L into c3, the coefficient of sine 3 pi x by L should be equated to the coefficient over here, which is nothing but minus v naught by 4. So just by doing so, I am getting the c3 answer as this. So if you go for any c4 or c5, you don't find enough terms on the right hand side to be equated, so that you can conclude that your c4, c5 and everything will be equal to 0. So just substitute the values what you have found out, which is nothing but your c1 and your c3, and those two values has to be again substituted in the equation 5. Your equation 5 is over here, which means it is not up to 1 to infinity, it will carry only the one term and the third term, which means instead of n, I'm going to substitute 1 over here on both the terms, and you know the c1 value, which is nothing but 3l v naught by 4 pi a. Then I have to include a plus symbol and then go for the third term, because I know the c3 value, right? Other than that, all the other constants are equal to 0. So this is what the required solution is. So this concludes our this particular session, where I have actually presented you both the formats of your wave equation. So if you have any doubts regarding this particular video, please do post that in the comment section. Let me try to explain you. And if you want any other private videos or any other offline courses, please do contact us. And for any gate mechanical related inquiries, you can follow me on Unacademy app. So I'll try to include the URL link where you can actually click and try to follow me. And for any offline classes, you can contact any of these 3 numbers. Thank you.